Day 574 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2872, maximum number of k-divisible components. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out the link in the description so you can get you some. Now let's see what the question says. There's an undirected tree with n nodes labeled from 0 to n minus 1. You are given the integer n and a 2D array edges of length n minus 1 where edges of I is equal to AI, BI indicates that there is an edge between nodes AI and BI in the tree. You are also given a zero index integer array values of length n where values of I is the value associated with the ith node in the integer k. A valid split of the tree is obtained by removing any set of edges possibly empty from the tree such that the resulting components have values that are divisible by k, where the value of the connected component is the sum of the values of its nodes. Return the maximum number of components in any valid split. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input n equals 5, edges equals a 2D array of integers 0, 2, the first array being 0, 2, next array being 1, 2, next array after that is 1, 3, and then the last array is 2, 4. The values is an array of integers 1, 8, 1, 4, 4, and k equals 6. The output is 2. Explanation says we remove the edge connecting node 1 and 2. The resulting split is valid because the value of the component containing nodes 1 and 3 is values of 1 plus values of 3, which equals 12. So let's break this down one step further before we continue, right? So first, these are our edges right here. Boom. And these are the nodes. So let's look at this picture for real. Let's look at this visual representation that they gave us, right? So we remove this edge right here. Boom. This edge right here, once we remove this edge right here, now we have two components. We have a component with 1 and 3, and we have a component with 2, 4, and 0. Now, when it says 1 and 3, it says right here the value, and we want this 1 and 3 to be divisible by k, right? So these values need to be divisible by k. The values are right here. So it says the value of the component containing nodes 1 and 3 is values of 1 plus values of 3, which equals 12. And 12 is divisible by k, which is 6. So we see this 1 and 3, you may be wondering, how did we get 12 from 1 and 3? Well, that's what this values array is for right here. We come to index 1, that's 8. We come to index 3, that's 4. 8 plus 4 equals 12, and that's where this 12 comes from. 12 is divisible by 6, or k, so this is a valid component right here. Now we need to check this component right here that we also created, right? So it says the value of the component containing nodes 0, 2, and 4 is values of 0 plus values of 2 plus values of 4, which equals 6. It can be shown that no other valid split has more than 2 connected components. So for this component right here, we have values 0, 2, and 4. So we come to values we come to value 0, that's 1. We come to values 2, that's 1. So right now we're at 2, then we come to values 4, that's 4. So 2 plus 4 is 6, or 1 plus 1 plus 4 is 6. 6 is divisible by k as well, so this makes it a valid component. In total, we have two valid components, this component right here and this component right here, and that's why the output is 2. So just in case that didn't make sense though, y'all, let's take a look at example 2. So in example 2, we have n equals 7, edges equals a 2D array of integers, first array being 0, 1, then 0, 2, then 1, 3, then 1, 4, then 2, 5, and lastly 2, 6. The values is an array of integers 3, 0, 6, 1, 5, 2, 1, and k equals 3. This time the output is 3. As we can see in this picture, we took this right here and we broke it up into 3 components. One component right here, one component is the 0, and one component right here. Let's look through the explanation so we can make it make sense, so we can see how they did this. So in the explanation says we remove the edge connecting the node from 0 and 2, which is this edge right here, and then the edge connecting 0 and with 1, which is this edge right here. So we remove this edge and we remove this edge, and in the end we're left with these three components right here after moving this edge right here and this edge right here. Boom. It says the resulting split is valid because the value of the component containing node 0 is a value of 3. So we're looking at node 0, k equals 3. We come over the values and we look at index 0. 0 is 3. 3 is divisible by 3. So that means this 0 right here is a valid component. Then it says the value of the components containing nodes 2, 5, and 6 is values of 2 plus values of 5 plus values of 6, which equals 9. So values of 2 will be right here, 6. Values of, then what we need, values of 2, values of 5, 4, or excuse me, 3, 4, 5. So this would be values of 5 right here, and then this would be values of 6 right here. So it would be 6 plus 2 plus 1, that's going to give us 9. 9 is also divisible by 3, so that makes this right here, this component is a valid component. So far we have this is a valid component, and we have this right here is a valid component. Now let's check this component and make sure it's valid. It says the value of the components containing 1, 3, and 4 is values of 1 plus values of 3 plus values of 4, which equals 6. So values of 1 is 0. Values of 3 is 1, and values of 4 is 5. So 0 plus 1 plus 5, that equals 6. 6 is divisible by 3, so that makes this a valid component as well. And in total, it can be shown that no other valid split has more than 3 connected components. So that's why the output is 3 for these 3 components right here, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we are going to do is we are going to create an adjacency list for the tree or in nodes. So we're going to declare a variable. Sorry, I'll come right here. Declare a variable called ADJ. We're going to set that equal to a 2D array of integers. Come outside of that. We're going to open up the parentheses. We're going to say repeating, colon, it's just going to repeat a blank array to start, and we're going to say comma, count, colon, n. Boom. Then we're going to come underneath that, and we need to build the undirected graph by saying, we're going to come right here, we're going to say for edge, n edges, we're going to open up the brackets, and we're going to say let u equal edge, square bracket 0, comma v equals edge, square bracket 1. Boom. Then we're going to come underneath that. We're going to say ADJ, square bracket u, come outside of that, dot append, open up the parentheses, pass in v. Then we're going to come underneath that. We're going to say ADJ, square bracket v, come outside of that. We're going to say dot append, open up the parentheses, pass in u. Now we need a counter for how many components have a sum divisible by k. So we're going to come underneath this, declare a variable called components, and we're going to set that equal to 0 just to start. And now we're going to create our depth first search function that returns the sum of the subtree rooted at node. So we're going to use some recursion here. So we're going to create this function inside the main function, and we're going to say func dfs, open up the parentheses, we're going to say underscore node, colon, that's going to be integer, comma, underscore parent, colon, that's going to be an integer as well, and it's going to return an integer. Boom. Then we're going to open up the brackets. Then we're going to declare a variable called sum, and this is going to start with the node's value, so we're going to set that equal to value square bracket node. Boom. Then we're going to come underneath that and visit all children by saying for child in ADJ square bracket node, open the, then we're going to say where child does not equal exclamation point equals parent. Then we're going to open up the brackets, and we're going to add the sum returned by the recursive DFS function that we just created. So we're going to say sum plus equals DFS, open up the parentheses, and we're going to pass in child, comma, parent. Boom. Then if this subtree's total sum is divisible by k, it counts as a valid component. So we'll come underneath this for loop, and we'll say if sum mod k equals 0, then we'll open up the brackets and we'll say components, increment that by 1 by saying plus equals 1. Then we could come underneath that and return the subtree sum by coming right here, and we could just say return sum. Boom. Now we need to start our depth first search function from node 0 or the tree root, or by coming right here. By coming right here, we're gonna say DFS, open up the parentheses, we're gonna say 0, comma, -1. Boom, and then we need to return the total number of divisible components by coming underneath this, and we can say return components. Boom, that should be all she wrote, y'all. Let's give it a run. Make sure it runs properly before we submit it. Okay, we have a runtime error. Let's see where we went wrong. Let's see. Well, somewhere we went wrong. Let's see if we can find it, y'all. So give me a moment while I look through this. One moment, y'all. Oh, sorry, y'all. So this right here should be node. So child, comma, node, not child, comma, parent. Sorry about that. Now let's give this a run. And there it is. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 45 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.